Good morning or good afternoon, depending on where you are. I'm Chris Finagla from the Warning Decision Training Division. I'd like to welcome you to today's Storm of the Month presentation. Today's presentation comes to you from the Warning Decision Training Division here in Norman, Oklahoma. Our presenter is Andy Wood, who will be presenting Scanning Strategy Best Practices.
All right, so as Chris had mentioned, today's topic is scanning strategy best practices. And so, just using the spirit of Taylor Swift here, it's actually like a double presentation because we're actually going to spend some time talking about VCPs, and we're also going to talk a little bit about dynamic scanning strategies. So we kind of combine the topic into one for that. So what's the motivation for this webinar? So on the VCP side of things, it's just always a good reminder that your VCP selection should be based upon the weather that's going on, not necessarily concerns about or worries that this particular VCP might seem to make the radar break faster, because all the VCPs that are available are well within operating specifications. So it's just a reminder of that, because I know that tends to come up from time to time. Likewise with dynamic scanning guidance, sometimes it's very clear and sometimes it can be a little confusing. And so the things that are clear, I want to try to make as clear as possible. And the things that are confusing, I'm hoping to make them a little less confusing. So likewise, there's been a couple of studies in the last few years that have looked at VCP and dynamic scanning usage. And so just some of the things that have come out of these two papers, we've got the VCP 212 is definitely the most commonly used during severe weather, which is a good thing. That's what it's designed for. But in addition, when it comes to dynamic scanning, SAILS and MERL is used quite a bit. During storms that have been warned for wind and hail, the nearest radar has had some form of SAILS or MERL used in, say, 70 to 80% of those events. And then when it comes to tornado warned events, it actually increases to about 90 to 95%. So it's both of those tools are getting used quite a bit. So that's definitely a good thing. But what that research showed is that SAILS is used significantly more than MERL. And so it almost maybe to like an order of magnitude more. And so that suggests that maybe folks aren't the most comfortable of knowing when to use MERL. And so I wanted to talk a little bit about that later on. And then also they just found in general that when you're using these dynamic scanning strategies, the warning statistics tend to improve compared to when they're not used. Now there's a huge caveat with this, because this was all based on bulk statistics. So there's not really a cause and effect, it's just a correlation. But at least it's a good sign that when they get used, things do seem to be a little bit better. So at least it's not the opposite. So let me start by just going into the VCP side of things. And so when it comes to VCPs, what are just some of the different scanning strategy elements that go into setting one VCP apart from another? One thing will be the VCP space, which is, those are all the different tilts that are included in the VCP to observe a volume of the atmosphere. You also have the different waveforms used, like for instance, how the split cut is set up to do full sweeps of the different waveforms, whereas a batch alternates from pulse to pulse. You also have things like sampling strategies, like how long of a pulse length are you using? Are you using the long pulse or short pulse? What's the rotation speed of the radar antenna? And even, are you using an application that requires a certain number of samples to be used? All these different things help set one VCP apart from another. And then, of course, there's even just more general things like whether the VCP was designed for clear air or precipitation viewing. So as of Build 22, we've got 6 VCPs available. 2 of them are designed as clear air VCPs, and that would be VCP 31 and 35. And you've got 4 precip VCPs, which are 12, 112, 212, and 215. When you look at things, just kind of the out-of-the-box setup for the radar, you've got 2 different defaults for precip and clear air mode. For clear air mode, VCP 35 is the out-of-the-box default. And then VCP 215 is the out-of-the-box precipitation mode default, as I know most of you are aware of. But just as a reminder, this can be changed at the RPG HCI. So I know a common thing that a lot of offices like to do is say during the warm season, if your office tends to get more convective weather, you'll go ahead and switch that default to 212 versus 215. So that way, if the mode selection function switches you from clear air to precip mode, you just end up right away in VCP 212 if that's what you're planning on using for convection. Just one less thing you have to worry about. And so that's certainly something that a lot of folks do. Now, in our training in RAC and in some other places, when it comes to VCP selection, we use little charts like we've got shown here just to kind of help with the decision-making process. It's fairly simplified for maybe some more obvious situations, how you might go through looking at things. But what I want to do today is just go through the kind of like 4 main situations where you might find yourself with 2 or more VCPs that could, in theory, be used reasonably in different events, and just what might help you decide between them. But before I get to those 4 situations, I do wanted to put this little reminder out there, and it has to do with the mode selection function versus precipitation status at the radar. So when it comes to mode selection function, that is the tool that will switch you between clear air and precip mode automatically when you've got that enabled at the RPG HCI. Precipitation status, it's going to be, you can access it kind of in the lower rate part of the RPG HCI, and it will tell you when the radar is actually accumulating radar data or rainfall data. And, it also involves different parameters that will help you set, like, when do you go into that based upon the area of certain values like DBZ or, other things that lead to echo coverage. The important thing here between mode selection function and precipitation status is that these are separate processes. So just because the mode selection function changes your radar automatically from clear air mode to precip mode, that doesn't necessarily mean that the radar is going to start automatically accumulating rainfall data. Likewise, if the radar automatically gets switched from precip mode to clear air mode, that doesn't mean that accumulation is going to stop. And even in situations where you manually select certain VCPs, like if you manually select the clear air mode VCP, if you've got enough echo coverage, your radar will accumulate rainfall data. And so that's just something I think that people get confused about. So I just wanted to make that point. So with that in mind, the first situation I wanted to put out there was drizzle and light precipitation options. And for a lot of you, these situations may be reminders that you feel comfortable with and but I just wanted to put it out there for some people who maybe are a little less experienced. And so when it comes to drizzle and light precipitation, VCP 31 is definitely a very good option. Because it uses that longer pulse, it provides increased sensitivity so you can see some of those weaker returns. The downside to it is because it uses that long pulse, the maximum unambiguous velocity is going to be lower. So you really only want to use it when winds are weaker. When winds are stronger, VCP 35 is probably going to be a better option when things are drizzly and light. You don't necessarily need to be in a precip mode VCP when the accumulations aren't going to be that much, because the radar will still accumulate for you even though you're in clear air mode. So a second situation is kind of related to that, and that involves winter precip, which can involve any number of things from snow, sleet, freezing rain, any combination of the above, including some areas with liquid precipitation. So again, VCP 31, if the precip is light and the winds are light, is definitely a good option. Likewise, VCP 35 will also be a good option if the winds are stronger, but the precip is still light. Once your precip starts getting more moderate to strong, then VCP 215 is definitely going to be the way to go versus using the clear air mode VCPs. So the third option, or the third situation here, is going to be severe convection. So when I talk about severe convection, it's all the different threats, whether it's hail, flash flooding, winds, tornado, what have you. In these situations, in the vast majority of cases, 212 or 12 are going to be your best options. And I'll have a slide here in a little bit where I talk more about the differences between those two. But they've been designed for these situations, and they also provide you the most flexibility when it comes to sales and Merl use. And so they're definitely going to be the ones you want to lean in on in these situations. And most people do. But so one little caveat that this won't apply to very many situations, but there may be times where people want to look into this. VCP 215 can be very useful if you only have a hail threat, especially if that hail threat is marginal and the storms are very close to the radar. And the reason for that is with VCP 215, you do get a little bit better radar coverage in your VCP space above 10 degrees. And so when that part of the VCP scanning strategy hits that hail growth zone, or even maybe helps you see the storm top divergence a little better, VCP 215 could be helpful. It doesn't necessarily mean that you need to use it in those situations, but it's not out of the realm of possibilities. The big thing with severe convection is no matter what the situation is, what VCP you select, even what dynamic scanning strategies you use, don't just set it and forget it. You do want to periodically review your VCP and dynamic scanning settings just to make sure they still fit for the situation that you're in, because things are constantly evolving in those situations. And what was most important to you 2 hours ago, things may have changed and you might need to adjust things. So the fourth situation where you might see possible options in play is when you get large-scale widespread precipitation. Landfalling tropical systems are kind of the classic example of this, but even in some cases with larger extratropical systems, that could fall into this category too. And VCP 112 has been built for these situations because it uses that multiple PRF de-aliasing algorithm, and it really helps you reduce range folding. It takes a little longer for those scans to get collected, so it's not always the best for true severe convection, but in situations like this, it's very helpful. Now, the one caveat here, if your CWA is maybe situated a little further from the circulation center, you're dealing with some outer bands, maybe tropical cyclone tornadoes is a bigger threat for you, you might want to go with VCP 212 in those situations, because it's that nice balance of you're still using SE2, so you're reducing your range folding area, but it's getting more rapid updates that help with those convective warning situations, like if you have a tornado threat. So those are those four main situations that I just wanted to clarify. Now, I think this is my last slide on the VCP part of things, and so I'm going to spend a little bit more time here because I think this is kind of the bigger dilemma, kind of like the Doppler dilemma, in that you're with VCP 12 and 212, you have a couple of competing factors and you have to really worry about trade-offs. So I've got this table here with VCP timings. And so you can see that things are a little different between VCP 12 and 212 in terms of how long it takes for the volume scans to complete. So just as a reminder, with VCP 12, your scanning times are going to be shorter. And it doesn't use the SE2 algorithm, and that's part of the reason why it is a little shorter. But you also are going to have to deal with range folding a little bit more. Now, they have tools in VCP 12 that allow you to use different PRFs in different sectors and adjust where those sectors are. You get to manually select what PRF you're using if you don't like what the automated tools that are in there are using. But all of this requires more interaction from a human during warning operations, and it just depends upon what your staffing and other need requirements are in that situation. That may not always work best for you. So VCP 212 is certainly going to be a viable option. It's what most people use. But the individual volume scans do take a little bit longer, even though you do get that reduced range folding. Now, when you're just doing a standard VCP, the time difference really isn't huge. It's going to be maybe on the order of 20 to 30 seconds. But as you start adding those sales and Merl tilts, that time increases between the length between the two. And so if you're talking about a full sweep all the way up to 19.5 degrees, once you start getting to, say, sales times 3 or even Merl times 4, the time difference between a single VCP 12 and a single VCP 212 is going to be on the order of, could be 30 seconds, but it could be even up to a minute. And all that's going to depend on the PRF that gets used for VCP 212, because it changes things because of the requirements for the number of pulses that SZ2 needs. And so you end up in that trade-off situation of, do you want more frequent scans, but you're going to need more human oversight to make sure your data is the best quality possible? Or do you really want just the less range folding? You're willing to have a little less oversight because you have needs in other areas, but your updates are going to be a little slower. And so that's that dilemma you have to go back and forth with, just like with the Doppler's dilemma. So that was really all I wanted to say on the VCP side of things specifically here. So now we're going to pivot and go on to dynamic scanning strategies. And so when we get into dynamic scanning strategies, again, it's that trade-off theme is going to be a common one that likes to pop up. Because when you start implementing different dynamic scanning strategies, your goal is to adjust your volume scan to get more tilts where you think they're more valuable. And so typically that is going to mean get more tilts down low and get rid of tilts up high, particularly when you don't have things going on up high. So you don't mind having fewer tilts up high as a result. So the trade-off is, especially when you get into using sales and Merl, because those tilts down low take longer to complete, it can actually lead to getting less overall tilts. And so you want to make sure that if you do emphasize those lower scans, that's what you actually want to emphasize. Because if you emphasize those and it's wrong, it can hamper you. And so that's why you always want to make sure that when you're emphasizing those lower tilts, that's what's really providing you the best value because of that trade-off. So I know folks are probably familiar with these, but there's always some people who it's like you talk to them about dynamic scanning and like, can you explain this to me again? So like I just wanted to do a quick rundown of the three: AVSET, sales, and Merl. So I'm going to start with AVSET, which is the automated volume scan evaluation and termination algorithm. And so I promise there will not be a test at the end with the different acronyms, but just for reminders, AVSET is the tool that allows you to skip those tilts aloft when there's insufficient echo coverage. So what I want to do is show you just a quick example of what that looks like. So if we're here at 0.5 and we've got some echoes out there, as we move up, I'm going to kind of do this quick, but you'll see as we go up, we're going to go up to the 5-degree tilt here. And this is where AVSET will kick in, and it's going to start looking to see how much coverage there is. And as long as the thresholds aren't met, they're going to, and when I say they're not met, they're above the thresholds, it's going to keep scanning. So in this case, we're going to keep scanning up until we get to 8 degrees. And at 8 degrees, finally, those thresholds, there's not enough echoes to meet that threshold. So the radar is going to decide to terminate on the next volume scan. So whenever it meets that condition, it does one more scan. And regardless of how much coverage is on this scan, this is where it's going to end. Now, when it comes to guidance with AVSET, the one thing about AVSET is it's pretty straightforward. It's like those Capital One commercials. It's kind of a really easy decision, and that most meteorological situations are going to benefit from using AVSET. And so to use the Nike example, just do it. And the good thing is when you look at the fleet in general situations, pretty much everybody does. So AVSET's one of those things. I think everybody knows the guidance on it. People are using it. We probably don't really need to say anything more about it. So now let's talk about sales. So sales, the Supplemental Adaptive Intra-Volume Low-Level Scan, or scans. So what sales allows you to do is get those extra tilts on your lowest tilt per volume scan. For most people, that's going to be 0.5. For the lucky few of you who have those supplemental tilts below 0.5, it can be that tilt as well. The important thing to remember with sales, and this also it to a degree applies with Merl too, when you have these extra tilts added, it tries to distribute them evenly through the volume scan. And it does that not necessarily by tilts, but by time. And so what you'll see with a volume scan that has sales is that there's probably going to be fewer tilts between, say, the initial 0.5 and the first one versus the ones towards the end of the scan. So let me show you an example of what that looks like here. So if we start here at 0.5 degrees, I've got an example that uses sales times 2. If I go up to 0.9, you'll see the first sales tilt happens right away. So we've only made it up one scan, and now we're already hitting that first sales tilt. And then we'll get a few tilts in, and then that second sales tilts in. So we only had one between the first two 0.5s. Now we've got 3 tilts between the second and third. And then if I go forward from here, you'll see we think it's going to be 4 or 5 tilts before the volume scan ends. And so, but it's, no, that was different. So as you go up, you'll see those kind of differences in length, because when you're on those split cuts, those scans take longer versus, say, like the CD cuts at the top of the volume scan. So now let's talk about MRL, or the mid-volume rescan of low-level elevations. So this is different from sales in the sense that you're not just getting one tilt multiple times per volume scan. We're actually allowed to select anywhere from 2 to 4 scans and get one repeat view of those. And so what's nice about this is this extra run of tilts, again, happens about midpoint of the scan, but it lets you sample a little bit of a deeper volume, especially as you start to get to like medium into further ranges, depending on what it is you're trying to look at. And so just to kind of see that in example here. So if we start here at 0.5 and I go up slowly, we'll have a normal scan until we get to here to 4 degrees. And now Merl will kick in and we'll have our 4 scans. And then after that 4th Merl scan, now we go back up to 5.1 and we finish our volume scan. And then because I have AVSET enabled, it cuts off at 8 degrees. So before I try to even tackle guidance when it comes to sales in Merl, I think it's really good to just do like a quick history lesson on when things were implemented, because I think it helps understand how it tends to get used. So way back in Build 12, which is over 10 years ago now, that's when sales was initially introduced, and you were allowed to do one of those tilts per volume scan. And just as of note, that was actually the last build before the dual pole release, if that gives you a sense of timing. So it wasn't until you get to the Build 16 upgrades where you first get the ability to have dual pole data collected on the sales tilt, and that was in Build 16. And then with 16.1, you added what they called at the time mesosales, where you allowed up to 3 sales tilts per volume. So that's actually one of those things with mesosales. People really don't use that term anymore. Now we just call it sales times 3. But so if you ever got confused at whatever happened to mesosales, we just don't necessarily use that term very much anymore. It wasn't until Build 18.2 that Merl was introduced, and that again allows you to have those 4 tilts per volume. Build 20 had an interesting update as well that may have flown under the radar, pun intended, for some people. And with Build 20, they added an adaptable parameter that allowed data from those sales and Merl tilts to make it into precip. And so I have a slide at the very end about that as well. So I've told you about this timeline, so why does that matter? Well, the sales guidance got established early on, and that was pretty much that it should be helpful during severe weather. And I think people got the message and they started using it pretty quickly. So when you get to around that Build 16 era and they added those extra sales tilts capability, I think people just saw it as more of a good thing. And it was like, hey, I have more options. Great. And so, and especially, I don't have the graphic here, but if you go back and look at those studies and see how it's being used, it's like sales implementation just soared. No problems at all. When Merl got released, I think the guidance was less clear. People, I think, were more uncertain of when to use it. I think the prevailing thing at the time was like, oh, it could really help with QLCS. But until you actually got to see it in operation, it was kind of hard to say maybe it will work in this situation versus that situation. And so it never really got a whole lot of traction in use, at least for those first few years. So as a result, sales gets used a lot more than Merl. And there may be situations where Merl is actually more useful than sales. certainly more useful than maybe we originally suggested, but it's just, unless you can see it in action with some sort of objective measure, it's kind of hard to know. And I know that there are things that have been put out there, like we've tried to put together some guidance in our RAC training. I think some folks in Central Region have also put together some charts that I think can help people, but it's just, as far as I know, I don't know if there's really been something where people have really dove in and done like a true wide-scale objective look at sales MRL, what situations would be best. And so just to show you a hypothetical example, because a few slides I'll explain something that I'm planning on doing here over the next several months. Say you have a situation where you're worried about tornado genesis. And so I know if I ask 10 of you, like what would be the best layer to look at for tornado genesis, I'd probably get about 7 or 8 different answers. I just threw up something of, say, the lowest 10,000 feet, just for the sake of the example. And so if I highlight the lowest 4 tilts on here, you can see that all 4 of those tilts, when you're at least close to the radar, would all fall into that zone. And so if you use something like Merl times 4, you actually get more scans in that layer than you would, say, using sales times 3. Now, if that same storm is further away from the radar, sales times 3 is definitely going to give you more coverage. And so knowing some of what these situations are can help. But even more importantly than that, one of the big things is that once you get, say, outside of maybe 15 nautical miles, either of these options is probably going to be better for you than using neither of them. And so if nothing else, what I'm hoping is, if people have any reservations, it's not always necessarily about getting like the perfect right answer. It's just trying to find out which answer is going to be best based upon the trade-offs of the needs of the situation you're in. Now, I just showed you this nice, neat hypothetical example. Unfortunately, this is what the real world looks like. We'll have a storm here at far ranges that looks like it might have hail, and it's getting ready to enter your CWA. We've got this supercell here that's about medium range away, and it's looks like it might have a tornado with it that we're worried about. And then we've got this area over here where multiple threats might be in play. It could be flash flooding, there might be some marginal severe winds, or maybe even some small hail. So we have all these different things coming at play at different ranges. So that nice, neat hypothetical example really doesn't work well when it comes to providing guidance in a real-world situation. On top of that, when it comes to different threats, if you've got multiple threats in play, the regions of the atmosphere you really want to look at are going to vary. You know, like earlier I talked about tornado, say the lowest 10,000 feet may be the most important. With hail, if you're really looking for the hail growth zone, storm top divergence, things of that nature, you're probably going to want to focus more aloft. Wind is kind of a kludge of the two, where you might want to be looking for mark signatures or KDP cores, or then signs of severe winds near the surface. So maybe that layer from, say, 0 even as high as 20,000 feet might be important, depending on how high your freezing level is. So there's lots of complications. So I really like the analogy that the tropical folks use with the toes on the foot. And so really, when you have multiple threats, you really want to focus in on what your big toe is, and that's going to be your primary threat. And so whatever that primary threat is, that's probably what that sales Merl decision should be focused in on, is that primary threat. Now, because you have the option to adjust the number of sales or Merl tilts, you can adjust that number based upon what your secondary or tertiary threats are. And so if you've got, say, a tornado threat close, but a hail threat far away, that you might need to adjust things based on that. One of the big things, though, at least a little bit of work I've done so far on this, looking at the number of tilts and how sales and Merl usage impact the number of tilts you have available to you. When you do add sales and Merl, and your storms are, say, closer to the radar, an important thing to remember is it does increase the number of low-level tilts to some degree. It might, say, increases like 10%. Could be a little more, could be a little less. But if you increase those low-level tilts by 10%, a lot of times what it's going to do is decrease your upper-level tilts by, say, 20% or 25%. And so that's just something you always need to keep in mind with this. Is like, again, it's that whole trade-off situation. It's not necessarily a clear-cut right answer. You just got to pick what's best for you. So some ongoing work that I'm doing is I want to try to help provide some better guidance for our training. And so I've been trying to do some just objective measurements. So I've created a ton of spreadsheets to try to calculate how frequently certain tilts hit some of these preferred layers based upon a variety of factors. And so I've been looking at things like VCP, number of sales tilts, number of Merls tilts. If AVSET is enabled, what's the termination angle? I haven't had a chance to dive into it yet, but I'm going to look at VCP 212 and look at all the different PRFs because that has such an impact on the timing of the VCP, and just see how these numbers change. I even have some things in here. If you've got a supplemental low-level tilt, how does that impact the number of tilts in your timing as well? So my plan is over the next 6 to 12 months is to try to number crunch as much of this as I can, and then to update my guidance in the RAC lesson that talks about dynamic scanning based on these strategies. And as important, or if not more important, is to try to help keep it as simple as possible, because I think it is very complicated, especially in real-world situations. So anything I can do to try to help make things simple, I want to do. So this is really the last of my content slides, and this goes back to that update from Bill 20 I had mentioned earlier. And so one of the things that can happen in radar data, especially if you've got quicker moving storms, is that you can get these artifacts in your precip amounts that look a little like railroad tracks. And so when you add those extra scans per volume scan, it just makes this pattern much more apparent. You see these noticeable artifacts in your QPE data. If you update your adaptable parameter so that this enable use of supplemental scans is set to yes, you can change what looks like this to something more like this, where it looks more realistic. It provides better precip output. So I realize that this is an MRMS Q3 display, but you can see similar improvement in your just local radar rainfall totals as well. And so if there's one thing that you do after this webinar, if you're not sure if you've got that turned on, go ahead and look at your adaptable parameters and just see if that's turned on, because that's kind of like the AVSET thing. Like, that's something you pretty much just want on regardless. It should help you in all cases. So with that, let me just wrap up my presentation. Here are just some links. I'll leave this up here for a moment because this is kind of my question slide anyway. If you wanted to take a snapshot to see what some of these URLs are, there's a couple from the Radar Operations Center about VCP info and comparisons. I also have the links to the two weather and forecasting articles that I referenced at the beginning of the presentation there. Also, this will be the last of the WDTD led Storm of the Month sessions. So our session next month is titled Creating a Rotation Shear Nomogram for Tornadoes in California. And we are back to Christian from one of our field offices giving that presentation. And with that, that's all I have. So I'm ready to answer any questions.
With that, I'll go ahead and wrap us up for this series. Again, thank you to Andy. He did both our March and our April sessions for this WDTD-led Storm of the Month. So thank you, Andy, for a lot of the work you put into making these presentations. And we had a lot of interest, a lot of questions today, so I'm sure it was useful. Tuesdays at 1 p.m. Central is our new time, and you can see our next presentation here for late May, so you'll see an announcement coming out for that. And again, it will be a new registration link, so pay attention when that announcement is released. And we're always looking for more folks, so if you have ideas of Storm of the Months, please come out here, reach out to us, and be a part of this series, because there's a lot of good interactions that come out of this. So thank you again for attending, and we will see you all next month.